Whenever we are given two equations, something like a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0, these are called simultaneous equations. Now if you rearrange both these equations into the form y equals mx plus c, then each equation represents a straight line on a graph. So when we say solve simultaneous equations, what we actually mean is find the point at which these two lines intersect each other. That single point of intersection, that x and y coordinate, is the value that satisfies both equations at the same time. That is why we call them simultaneous. They are true together simultaneously. Hi, welcome to My Exam Revision. In this video, we'll be discussing simultaneous equations. This lesson is divided into 4 sections. In the first section, we'll discuss the elimination method, which is the method you will use most often in your exam. In the second section, we'll move on to the substitution method, which you must use when one equation is non-linear, for example, a quadratic. In the third section, we'll quickly cover the graphical method and discuss when it is actually used in the exam. In the fourth and final section, we'll work through a more complex past paper question on simultaneous equations.
I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Let's start with the elimination method. The idea is simple. We have two equations and two unknowns, x and y. If we can add or subtract the two equations in a way that one of the variables cancels out, we are left with one equation and one unknown, which we can easily solve. Let's start with a very basic question. We are given 3x plus 2y equals 16, 5x minus 2y equals 8. There are two important pieces of information. First, both equations are linear. Second, look at the y terms. One has plus 2y and the other has minus 2y. They are already opposite in sign and equal in size. Step 1 is always to look at the coefficients and decide which variable to eliminate. Here, the y terms will cancel if we add the two equations together. Step 2 is to add the equations. 3x plus 5x is 8x, plus 2y minus 2y is 0, and 16 plus 8 is 24. So we get 8x equals 24, which gives us x equals 3. Step 3 is to substitute this value back into either of the original equations to find y. Let's use the first one. 3 times 3 plus 2y equals 16, which gives 9 plus 2y equals 16. So 2y equals 7, which means y equals 3.5. So the solution is x equals 3, y equals 3.5. Let me give you a quick rule that you must remember. If the signs of the matching coefficients are the same, you subtract the equations. If the signs are opposite, you add the equations. A simple way to remember this is same sign subtract, different sign add, or SSS DSA. Now let's try a question where the coefficients do not match. We are given 2x plus 3y equals 13, 4x plus 5y equals 23. Here, neither x nor y has matching coefficients, so we need an extra step at the beginning. We multiply one or both equations until one of the variables has matching coefficients. Let's eliminate x. The coefficient of x in the first equation is 2, and in the second equation it is 4. So if we multiply the first equation by 2, the x terms will match. Multiplying the entire first equation by 2 gives 4x plus 6y equals 26. Now our two equations are 4x plus 6y equals 26 and 4x plus 5y equals 23. The signs are the same, so we subtract. 4x minus 4x is 0, 6y minus 5y is y, and 26 minus 23 is 3. So y equals 3. Now substitute y equals 3 back into the original first equation. 2x plus 3 times 3 equals 13. That gives 2x plus 9 equals 13. So 2x equals 4, which means x equals 2. So the solution is x equals 2, y equals 3. So elimination is your go-to method whenever both equations are linear. Match the coefficients, add or subtract, solve for one variable, and substitute back. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, myexamrevision, I have created a full worksheet for each topic. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions, all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level Maths and further Maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now, let's continue to the next part of the video. The substitution method is the one you should use in two specific situations. The first is when one of the equations already has a variable on its own as the subject. For example, y equals 2x plus 1. The second and more important situation is when one equation is linear and the other is non-linear. For example, a quadratic. In that case, elimination simply will not work and you must use substitution. Let's start with a simple example. We are given y equals 2x plus 1, 3x plus y equals 11. The first equation already tells us that y equals 2x plus 1. So instead of dealing with two unknowns, we can substitute this expression for y straight into the second equation. Step 1 is to substitute. The second equation becomes 3x plus in brackets 2x plus 1 equals 11. Step 2 is to remove the brackets and solve. 3x plus 2x plus 1 equals 11. Combine like terms. 5x plus 1 equals 11. Subtract 1 from both sides. 5x equals 10. So x equals 2. Step 3 is to substitute x equals 2 back into the equation for y. Y equals 2 times 2 plus 1, which gives y equals 5. So the solution is x equals 2, y equals 5. Now let's move on to the more important type of question, where one equation is linear and the other is quadratic. We are given y equals x square plus 1, y equals 3x minus 1. Both equations are equal to y. So we can set the right hand sides equal to each other. That gives x squared plus 1 equals 3x minus 1. Now rearrange everything to one side to form a quadratic equation. X squared minus 3x plus 2 equals 0. Now factorize the quadratic. X minus 1 to x minus 2 equals 0. So x equals 1 or x equals 2. But we are not finished yet. We also need to find the corresponding values of y. Substitute each x value back into the linear equation y equals 3x minus 1. When x equals 1, y equals 3 times 1 minus 1, which is 2. When x equals 2, y equals 3 times 2 minus 1, which is 5. Finally, write the answers as coordinates. The solutions are 1, 2 and 2, 5. This makes sense because a straight line can cut a parabola at 2 points. So we expect 2 pairs of solutions. So substitution is your go-to method whenever one variable is already isolated or when one of the equations is non-linear. Now let's quickly cover the third method, the graphical method. The graphical method is exactly what it sounds like. You take both equations, plot them as straight lines on a graph, and the point at which the two lines cross is your solution. Let's take an example. Suppose we have y equals x plus 1 and y equals minus x plus 5. For the first line, the y-intercept is 1 and the gradient is 1. So we plot the point 0, 1 and from there go up 1, across 1 to plot the next point. Join them with a straight line. For the second line, the y-intercept is 5 and the gradient is minus 1. So we plot the point 0, 5 and from there go down 1, across 1. Join them with a straight line. Now look at where the two lines cross. They intersect at the point 2, 3. So the solution is x equals 2, y equals 3. Now here is the important thing you need to remember. In your GCSE exam, you should only use the graphical method when the question specifically asks you to or when you are given a graph to read off. The graphical method is slow and the answer is only as accurate as your drawing. If your line is even slightly off, your answer will be wrong. So for normal exam questions, always use elimination or substitution. The graphical method is mainly used when the question gives you a graph of two lines and asks you to write down the solution by reading off the point of intersection. Now let's look at a more complex past paper question. We are given the equations y equals x squared minus 4x plus 5, y equals 2x minus 3. Part A asks us to solve these simultaneous equations. Part B asks us to interpret what the solutions tell us about the line and the curve. Let's start with part A. Since both equations are equal to y, we set the right hand sides equal to each other. X squared minus 4x plus 5 equals 2x minus 3. Now rearrange everything to one side. X squared minus 4x minus 2x plus 5 plus 3 equals 0. Combine like terms. X squared minus 6x plus 8 equals 0. Now factorize the quadratic. X minus 2 times x minus 4 equals 0. So x equals 2 or x equals 4. Now find the corresponding y values by substituting into the linear equation y equals 2x minus 3. When x equals 2, y equals 2 times 2 minus 3, which is 1. When x equals 4, y equals 2 times 4 minus 3, which is 5. So the solutions are 2, 1 and 4, 5. Now part B. What do these solutions tell us? Because we got two pairs of solutions, this means the line cuts the parabola at exactly 2 points. Those 2 points are 2, 1 and 4, 5. If we had only got one solution, the line would be a tangent to the curve, touching it at exactly 1 point. And if the quadratic gave us no real solutions, that would mean the line does not intersect the curve at all. This is a very common place where exam questions test your understanding, so make sure you remember this. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.